So this is the last lesson of this unit. A quick recall, what have you been doing in this unit? Solving quadratic equations. Now you have 4 different ways to do it. We have factoring, we have perfect squares, completing the square, and using the quadratic formula. For this test, I will tell you which method you're going to use. Okay, so you won't have a choice. If I say you need to solve by factoring, you have to solve by factoring. If you want to solve by quadratic formula, then I'll ask you to do that. Okay? But after this unit, you're going to have to decide what method to use. And like I said, you can always use a quadratic formula, but it's going to be kind of cumbersome. It's going to take a long time. What you really want to be able to tell is if something can be factored or not. Okay, and the idea of using the discriminant is one way to tell if something can be factored. Okay, so let's take a look at what the discriminant is. The discriminant is this part of the quadratic formula right here. This part that's in the root. b squared minus 4ac. Okay, it allows you to state how many solutions and what kind of solutions. Okay, so let's take a look at an example. We saw one previously where what was in the root, the discriminant, was negative. Okay, now where was that? Let's go back here. This one right here. When the discriminant, the value in the root, was negative, we said that there were no real roots. Okay? So if it's negative, there are no real roots. Okay? What happens if the discriminant, what's in the root, equals 0? So let's picture this for a second. What if you had a 0 for one of these examples? So what if you looked at this example and you found out that this whole thing right here was 0? Well, you would be left with just 5/4, because the plus or minus part would be a 0. Okay? So what happens is if the discriminant is 0, we have only one answer. We have one real solution, or root. Okay? Then let's look at if b squared minus 4ac is positive, if it's greater than 0. Well, then you're going to have 2 roots. But this is the one that's important because it's more than just 2 roots. It depends. Okay? There are going to be 2 roots. They will be real if b squared minus 4ac is a perfect square. Actually, it's more than real. It'll be rational. And the root will be irrational if b squared minus 4ac is not a perfect square, a non-perfect square. Okay, so let's try a couple and see what's going on here. So it says, without solving, determine whether the equation has 1, 2, or no roots. So we'll go b squared minus 4ac. So negative 6 squared minus 4 times 9 times 1. This equals 36, take away 36, which equals 0. This means there are, this means there is 1 root. It's a rational root. 1 rational root. Rational means that we can write that number as a fraction. Okay? Let's try the next one. So this time we would get negative 5 squared minus 4 times 3 times 1. So you get 25, take away 12, which is 13. This tells you there are 2 irrational roots. Okay, 13 is greater than 0, so there are 2 roots. It's not a perfect square, so it's irrational. Okay. Let's try this one. Negative 2 squared minus 4 times 12 times 1. So this is going to be 4 take away 48. So this is negative 44. This means no real roots. There will be imaginary ones, but not real ones. Okay, and then let's just do one more here. Let's go D, and let's come up with let's go x squared minus 6x plus 8 is 0. So then we would have negative 6 squared minus 4 times 1 times 8. So this is 36 take away 32, which is 4. What does 4 tell you? It's positive, so there's 2 roots. It's a perfect square, so they are 2 rational roots. Now, why do we care about the difference between irrational and rational? If it's a rational root, that means this one could be factored. It's factorable. Okay, now we will use that in the future. We will not use it in this unit, but a good way to tell if something can be factored is to find out if it has 2 rational roots. Is a discriminant a perfect square? Okay. Example 2, the values of the discriminant are given. So this time we don't have to figure it out, they're given. And we just have to say, what kind of roots are they? Are they rational or irrational, or can we factor it? So if the discriminant is 0, what does that mean? 1 rational root. Okay, this one cannot be factored. Okay, 81. Positive, perfect square. 2 rational roots. And this one you can factor. The discriminant is negative, 0 real roots. You can even say 0 roots because we're not going to deal with imaginary numbers. Here, positive, so 2 roots, not a perfect square, so irrational. Okay. Hopefully that makes sense. Now, it's kind of, you're not going to really use this in this unit. Well, I'll ask you some of these questions just like I did in the notes here, but we will use this in the future to decide, can I factor something? Okay. Last couple questions for this unit. There's always one of these that shows up. I'm going to give it to you real quickly here because I think I'm not going to ask this on the test this year just because we're in a little different situation. But let's take a look at it. It says determine the values of k so there are no real roots. If there are no real roots, this means it's going to be less than 0. So that means my discriminant is less than 0. So let's plug in what we've got. This means 7 minus 4 times 2, and c is actually k. So we're supposed to find out what value of k works here. So 49 minus 8k is less than 0. Do you remember how to solve inequalities? Well, to solve an inequality, you treat it like it's an equality, and you only have that one condition if you divide by a negative. So I can take the 49 to the other side, and then if I divide by a negative 8, the inequality sign changes direction. So what this is saying is if I have a k value that's bigger than 49 over 8, there will be no root. Okay? Just for interest's sake, what if I, instead of saying no root, I said I want one root? If I wanted one root, I would change this question by saying equals 0 instead. And you would do the same question, so your final answer would be k equals 49 over 8. Okay? So we can change these questions just by, small little variations in the way we solve. Okay, so in this case, if k is bigger than 49 over 8, we have no real roots. Use one value of k to write an equation that has no roots. So let's put a value of k in, so there won't be any roots. Well, k would have to be bigger than 49 over 8. 50 over 8? Sure. If you're not sure, put 100 over 8. That's for sure bigger. Okay, as long as it's bigger, you're going to have an equation that works. All right, here is the end of the unit. I've written in here practice test tomorrow. That won't be happening. But I do want to remind you there is a cumulative review with lots of good questions. And believe me, you cannot get enough practice with factoring, with solving using quadratic formula, with completing the square. I have lots of questions for you here. Lots of them. Okay, please practice. Please get good at this. It's up to you.